Welcome. Today I'm going to be talking about how to find the chemical formula from the chemical name for ionic compounds. So first I'm going to give you a few steps to find the chemical formulas. Then I'm going to give you some practice problems, and I will also provide some extra examples so you can check your progress with this topic. Alright, so on the left here we can see the steps to find the chemical formula from a given chemical name for ionic compounds. So here we're going to find the element symbols, then we're going to find the ionic charges, then we're going to determine how many of each atom we need in order to make the entire compound neutral. Alright, so let's try out this example. Calcium carbonate. What is the formula for calcium carbonate? So we know that calcium is represented by Ca, and carbonate is represented by CO3. It is a polyatomic ion with a -2 charge. Additionally, we know that calcium has an ionic charge of +2. And so now we are going to check how many of calcium and how many of carbonate do we need to make calcium carbonate neutral. If we put 1 and 1 together, we have a +2 minus 2, which is 0, which is neutral. So that means we only need 1 calcium, and we only need 1 carbonate to have calcium carbonate. So let's try another example. Okay, so we have aluminum sulfate. So aluminum, our first step is to find the element symbol. So aluminum is Al. Sulfate is a polyatomic ion, SO4, -2. All right, and then aluminum has a +3 ionic charge. Okay, next we are going to find how many of each, how many aluminums and how many sulfates we need to put together. At this point, if we put 1 and 1 together, we have a +3 minus 2, which is +1, which is not yet neutral. All right, so what we're going to do is find a common multiple of 3 and 2. We want to find the smallest multiple between them. Okay, and so the smallest multiple between these is going to be 6. So in that case, we know that we're going to get a +6, and we're also going to get a -6, t equals 0. Okay, so aluminum is going to provide the +6 part, so we need 2 aluminums for that. And the SO4 is going to provide the -6. Okay, so we need 3 sulfates, all right, to have a -6 charge. Okay, and so Al2SO43 is going to be our final answer. All right, so let's try another one. Magnesium chloride. What is the chemical formula here? All right, so magnesium is represented by Mg. Then we have chloride, which is represented by Cl. Now we're going to find the ionic charges. So Cl is -1 and magnesium is +2. So the question is, how many magnesiums and how many chlorines do we need to put together to make magnesium chloride neutral? So at this point, if we put 1 and 1 together, so we have a +2 minus 1, that's going to be +1. Now we will find the smallest multiple between 2 and 1. And that is going to be 2. So we're going to have a 2 minus 2. Okay, and so magnesium will, of course, provide the positive part. So we'll have 1 magnesium, okay, because to be 2, we just need 1. And then chlorine will provide the -2 part. And so we need 2 -1s to be equal -2. Okay, so we'll have 2 chlorines as such. Okay, so MgCl2 will be our chemical formula here. Now, so far we have practiced finding a chemical formula for compounds with a main group metal. Now we're going to find the chemical formula of ionic compounds with a transition metal. Okay, and the only difference here is that the charge of the metal is already given. Okay, and so copper oxide. Well, copper is represented by symbol Cu. Oxide is oxygen, and that will be O. Okay, in this case, they're telling us that copper has a +3 charge, and we know from the periodic table that oxygen has a -2 charge. And now our task is the same, to determine how many coppers and how many oxygens we need. At this point, we have +3 minus 2 if we put 1 and 1 together, which is not yet neutral. Okay, so we will again find the smallest multiple between 3 and 2. So that is going to be 6, so we'll have a +6 minus 6. So guess what? Copper will contribute the positive part. So to get to +6, we need 2 coppers. All right, and an oxygen will contribute the negative part. So we can say that 6 divided by 2, right, is going to be 3. So we need 3 oxygens. All right, and so Cu2O3 is going to be our chemical formula. So let's try another one with a transition metal. In this case, we have lead 2 nitrate. So lead is represented by Pb, and nitrate is represented by NO3. All right, so lead, it tells us it has a positive 2 charge, and nitrate is a polyatomic ion with a negative 1 charge. Now we're going to find out how many leads and how many nitrates we need to put together. Currently, if we try to put 1 and 1 together, we have a plus 2 minus 1, which is not yet 0. So we're going to find the smallest multiple between 2 and 1. Okay, that's going to be 2, so we're going to have a 2 minus 2, which is 0. Okay, and so lead will contribute the positive part. So we'll need 1 lead, okay, because 2 divided by 2 is just 1. And then for nitrates, well, we'll have 2 of those because we need a negative 2 in total. So PbNO32 will be our chemical formula for lead 2 nitrate. So what is the chemical formula when we have vanadium 3 phosphide? So first we will find the chemical symbol. So vanadium is a transition metal with symbol V. Phosphide is phosphorus with a P. And we know that the ionic charges are as follows: positive 3 for vanadium and negative 3 for phosphorus. If we put 1 and 1 together, we have 3 minus 3, which is 0. So that means we only need 1 of each atom for this compound. Okay, and so Vp will be our chemical formula for vanadium 3 phosphide. So now it's time for you to check your progress here, and you can write the answer in the comments. So your job is to find the chemical formula of aluminum chloride and vanadium 3 oxide. Thank you so much for watching this video.